Good morning, everyone. I hope you are doing all right. Uh, hopefully, it's the microphone. Hopefully, it's working now. Okay. And we are just getting started. When I was writing this, I wasn't talking. So far in this class, we learned about definition of physical quantities like position, displacement, velocity, acceleration, and we learn about the relationship between them. Okay. So those relationships are called kinematics. And then we also learned that some of the physical quantities are vector quantities. Actually, most of these physical quantities are vector quantities. So when we have to add or subtract them, they don't just follow the rules, simple rule of adding numbers or subtracting numbers. So we have to follow a special rule. So we learn about vector subtraction while talking about finding the direction of acceleration from initial and final velocity, because direction of acceleration depends on change in velocity vector, vf minus vi, and that was the vector subtraction. And once we move from one dimension to two dimension, rather than just going east and west or up and down, we may also go sideways. So in that case, we also need to learn how to add vectors to get the displacement, okay? And that's what we did last class, towards the end of last class. And for review, I am bringing them here. So for example, if I'm adding two vectors, and those vectors could be pointing in any direction, this just example, right? B and C, these are just example. So they could be pointing in any direction, doesn't matter. So you bring one vector, you draw one vector first. So here I'm drawing B first, but you could also draw C first if you like, okay? And then bring the tail of the second vector to the tip of first vector. Remember, while subtracting, we did tails together, but while adding, we're not doing tails together, rather tail to the tip. See, tails and tip. Tail and tip are together. So that's that. And then now, that's the step one. So now it's time to draw the sum vector. Or in this case, if these happens to be position vectors, then this would also be the displacement vector. So this being initial position, initial point from where object starts to move, and for this case, it being final, remember displacement vector we draw from initial position to final position. And that drawing is like a aerial distance, straight, okay? So that's why you see in the second step, we are doing this. So from a tail of first vector to the tip of the last vector, right? So that gives you a displacement. So this number B, so let's say if the length of the B is 4 and length of the C is, let's say 5, then path length we travel gonna be 4 plus 5. But how about displacement? Displacement is not 4 plus 5, it's not 9, okay? It's a vector sum. So it has to be, we have to calculate this length using geometry. And if they are pointing right angle to each other, then we can use Pythagorean theorem, right? So if this angle is 90 degree, or let's say if this angle was 90 degree, then this value of this resulting vector would be b square plus c square under the square root, okay? Sum. If this angle was 90 degree. If it's not, then it doesn't work quite that way. We have to follow slightly different rule. But for now, for our purpose, we're going to be mostly talking about perpendicular vectors in our application. So I'm just focusing on that one first. So let's make sure you learn that, okay? So this one we already talked about last class, okay? This one is just the, review. So now what I'm doing is I have this question. This question was asked in the MCAT. So it talks about walking 30 meter east, 40 meter north. So these are the position vectors, right? So if these are two vectors, you can draw them by following the rule and then find displacement vector. But in this question, it's not just asking for displacement, rather it is asking for difference between distance and displacement. See, the MCAT is famous for combining different concepts in one question. And in this case, you see, it's not just asking for distance, it's not just asking for displacement, it's asking for difference between them, okay? It may not even look like a physics problem, but it is actually a physics problem, okay? So I'm opening the pool, and you have a minute and 30 seconds to answer this question. Or maybe 2 minutes. You may need a calculator. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, I'm getting a message saying my clicker is not working. It keeps saying that is expired. Yeah, you have to pay for it. At the beginning of semester, I said there may be 1 or 2 weeks of trial period. After that, you have to pay it. It costs around $16 or so. Okay. Okay, let's see how did we do here. So mostly B, and there are C and D. So how do we do it? So we have one vector that's going to the east. So 30 meters. Another one going north. So let's say this up as a north, usual compass notation, 40 meters. So I'm drawing them. See how the tail is on the tip. So now I'm ready to find the displacement. So that gives me displacement. And distance is simply path length, right? So that means it's going to be just 30 plus 40, which is 70 meters. Displacement, on the other hand, let me just write this, gonna be 30 meters squared plus 40 meters squared. I'm using Pythagorean theorem here to find the value of that. See, when you go from east to north, you are turning exactly 90 degrees. So this is right triangle. So because of that, you can use Pythagorean theorem here, okay? And that gives us 50 meters, okay? So now it's asking us to find the difference. So difference between 70 and 50 is 20 meter, just like most of you identified. So some of you chose C. Most likely that means you just found the displacement, right? It's 50. You simply found the displacement, but you forgot to find the difference between distance and displacement. And D would be, I guess D is simply the distance. And A, 0 meter. I don't know how you get that, but anyway, so that's how we add two vectors, okay? So here, if you pay attention, this is sum vector, and this sum vector comes from the components. There's 30 meter going to the east and 40 meters going to the north. Individually, these are also vectors, right? That's why we drew it with the line with an arrow, okay? So that means sum of these two vectors, 30 and 40, is this displacement here, or this vector here. So 30 plus 40 is 50. Kind of interesting math, isn't it? So that's why we say, okay, it does not follow the numbers. So now next, what we want to do is, let's suppose we are given something like this. A main vector is given, and we want to find its components like this and that. What is this? What is that? Knowing this, okay? And that's called finding components. And why we want to do that? Because when we solve problem in 2-dimension, we want to, rather directly solving in, the problem as a combined problem, what we want to do is we want to break that into two components, horizontal and vertical components. And we have already learned how to solve problem in horizontal direction using kinematic equation. And similarly, in vertical direction, for example, free fall. So what happens is when we throw an object on the air, even if we don't throw it straight up, what happens? When we throw it sideways, it kind of moves in a plane, 2-dimensional plane. Actually, it's going to be 3-dimensional, but we can still just keep that in 2-dimension. So in that case, what we can do is we can break that into horizontal and vertical component and use those and combine them to get the answer. So for that purpose, we need this skill of knowing, how to write a given vector in horizontal and vertical direction or in component form, and then also how to combine them using the method we just saw in the last slide. So, and with that mathematical tool, we will be able to analyze this problem where object goes sideways. And when we do that by throwing an object in the air where air resistance is negligible, we call that projectile motion. And that's the main topic for today. Okay, so finding component is not just important for a projectile motion, but it's going to be important for, let's say later, while using any vectors like force, where we talk that in laws of motion. So understanding this skill inside out is very important, okay? So If you are distracted somewhere, pay attention, okay? Give your 100% and learn this, okay? And you want to learn it now, right here, right today, okay? So for that, you need these trig identities. And in one of the basic trig video that I posted even before this class started on Canvas, right? That has these things defined and how they work. So probably some of you may remember by you know, this SOHCAHTOA thingy, okay? But the cosine, so what these trig function doing is they are relating one angle of a right triangle with two sides of a right triangle. Right triangle is a triangle that has that has at least one angle 90 degree, just like we saw over there. And if we are given a vector, we can make a right triangle out of that. So we make that given vector a hypotenuse of that right triangle. And then we draw two sides that are perpendicular to each other. And that those two sides turns out to be, or what we call, component of that vector, okay? So in this case, let's say the vector is b, or could be any vector. This applies to any vector. Once we know a vector, what we know is its value and its direction. So direction can be written in terms of physical direction or could be written in terms of angle. So here I am writing this angle with respect to horizontal line. So this horizontal line, vertical lines, when we draw them, we call them x-axis and y-axis, right? So we design them, or we put them at the tail of given vector, which we are trying to find components of. So we do that. And then our goal is to start here and reach over there on the tip. Start from the tail and reach to the tip. But we are not allowed to move other than horizontal and vertical direction in this case, or in other words, along the x-axis and y-axis. So for that reason, to arrive to B, first I have to move either in this direction along the x or along the y direction, okay? Either way is fine, but what is the preferred one? Which one we want? If we are given angle, we want to go first on the side where the angle is. See here, this angle we don't know. So that's why we do not want to go like that here, okay? So we want to enclose that angle, okay? So that's what I am drawing here. And the one that's pointing along the horizontal direction, or our chosen x-axis, we call that x component. And one that's pointing along the y-axis, see, y-axis is vertically up, and this is also vertically up. And so that means this by is pointing along the y. So y, by, it is the y component of v. bx, this is the x component of v. And notice, although I'm saying bx, by, it is actually x is subscript, okay? It is not vx like that. It is v and subs x like that. So that's how you want to practice, okay? So that's how we write components along the horizontal and vertical direction, or chosen x and y axis. Oh, it writes, but it does not erase. Is my pen not working? Okay, still writing. So that's what, so now see how we made a right triangle. And then in the process of right triangle, we drew these components, okay? And now we want to find the component. So now to find the component, see, this B is known, this angle is known. Even if the angle is not known, what you want to do is you want to put one angle there and say, okay, it's a theta, or some symbol for, or notation for the angle. here, often we use theta for angle. Sometimes we may use some other things like phi, alpha, some, like that. So often we will be using theta for angle. Any angle, we may write theta if there is only one angle. But if we need more than one angle, then we have to find other notation as well. Okay, so now what we want to do is we want to, let's say, find this x component. Means we want to find this side length of this triangle. Okay, and we know hypotenuse by drawing. This is hypotenuse, and this being 90-degree, opposite to the hypotenuse, opposite to that 90-degree is the hypotenuse. I'm just writing h for that. Okay, so we want to find this x component. So for this right triangle, do you know what this x component, which side that x component represents? We already have hypotenuse, so this is not going to be hypotenuse. What other two sides we know? Opposite and adjacent, right? Is this opposite or adjacent? Can you type that on the chat? The x component, is this opposite side or adjacent side for the given angle? Okay, I see a couple of responses there, and mostly adjacent, and that would be right. Okay, so this is adjacent. So we want adjacent, we know hypotenuse. Okay, so now we need to look at, okay, what is the trig function that relates adjacent and hypotenuse? So which function? Is it sine, cosine, or tan that relates adjacent and hypotenuse? Can you type that on the chat? Is it sine, cosine, or tangent that relates adjacent and hypotenuse? So it's a cosine. So that's how you need to look. So this one, it has to be in your head. Okay. So that means we want to start by writing, let's say, cosine then. Okay. So cosine is adjacent over hypotenuse, but for our triangle, adjacent is actually x component of the given vector that we are looking for. And hypotenuse is the given vector, original vector v. So now I'm looking for x component, so I can solve this equation for x component. Okay. So now once I have that, this being a vector, so this is the value of the x component. How about direction? And for direction, we need to identify whether it's a positive sign or a negative sign. Okay. So in this case, Vx, or the x component, is pointing right along the x direction, not to the opposite. Okay. So if the Vx was pointing opposite like this of this positive x, so that would be negative. But here it's pointing right in the direction of this positive x. So that's why it has positive sign. So we write positive v cosine theta. So you may think, okay, positive versus not writing positive, what's the difference? Remember, although mathematically it is correct to write without positive sign, if there is no sign, we assume that is a positive sign. Nothing wrong with that. But by writing this positive sign, I am making sure that I look for the direction of that vector quantity. I did not miss it. Okay. So when I write explicitly positive, I know I checked for the sign. This being a vector quantity, its direction is given by either positive or negative sign. So by writing explicitly that, I am making sure that I checked for it. Okay. So yes, sometimes you may see this positive sign not written there. If it's not, then if it is a vector, then you need to assume that is a positive. But when you are doing it, you want to write it, okay? So that you checked for the sign. Okay, so that's that. So now we found the x component. Now what's next? We want to find the y component. So we repeat this process, okay, this use trig function and determine the sign. So this step 3 and 4, we repeat that. And so now y component, what side is this? Is this adjacent or opposite? Since the x component is adjacent, the y component is opposite. So it's obvious, right? So this is opposite now, opposite of this angle. This is adjacent to this angle. This is opposite to this angle. Okay, so that's how we look at it, right? So now that means we have to include opposite and hypotenuse. Remember, in both cases, we want to include hypotenuse because we know the hypotenuse from given vector. From the drawing, that's hypotenuse. So that's why when we are writing components, it's going to be either cosine or sine, okay? But any one could be sine or cosine depending on which angle we are looking for. So that's why we need to know how to do it rather than just remembering, hey, looks like x is going to be always cosine, but it is not. It's not always cosine, could be sine, okay? We'll see some examples soon. So that's that. So now this being opposite, so opposite and hypotenuse are related by, if I look at this list here, it's related by sine. So just like it picked up cosine here, it's going to pick up sine. And it's pointing up just like positive y, so it's going to have sine positive as well. Okay? So if once you identify one is cosine, another must be sine. And another thing you want to keep in mind while focusing on sine and cosine, while writing this, is to often forget about the original vector. Remember, it's the component of original vector. So that original vector times the cosine or sine. So that's how it has to be. So that's how we find component of a given vector. So for some of you, it's going to be, it may be enough, but for most of you, you may need more practice. So there is a question, is it not positive vi sine theta? Oops. It's not by. See, just like there is no bx here, there is no vi here. Bx is the name of the component. Bx is the name of the component. What's its value? The given vector v, original vector v times cosine. Okay. It is not by here. Otherwise, this is not vx or vy here. Otherwise, this vy cannot be vy times sine theta. It's like saying 2 is equal to 2 times something else. Cannot be. For example, let's say if that happens to be 2, then see, this equation not going to be true. Okay? So it is not Vy sine theta. It is simply V sine theta. The original vector times that. Vy is the name of the component. So Vy is the name of the y component of given vector. And its value is given vector times sine theta in this case. And its direction is positive. Okay, so that's how we write it. Thank you for asking. Hope I explained that. Okay, so now here are some practice situation. Okay, so one, we already did it. Okay, something like that we had in the previous slide that we did. Our V was something like this, positive X, positive Y. Okay, so we already did one of this. So we can have like this vector pointing in any one of the 4 quadrants. So this is first quadrant, this is second quadrant, this is third quadrant, or this is fourth quadrant, right? So could be pointing that way, could be pointing that way, could be pointing that way. And The angle that we know could, two possibilities, one along the x-axis, another one along the y-axis for each of these. So there are possible 8 situations, 5 plus 3, 8 situation, okay? So here I have drawn 6 of them, okay? 6 different situations for practice, but you can go through the practice of all 8 of them if you like. One out of 8, we already did that, so there are 7 more. But here I'm drawing 6 of them. So as you can see, there are angles sometimes given with the y-axis. And by the way, y-axis is here. This is positive. This is positive. I did not keep on writing positive x and y. It's understood. All of them are y and x, just like in the first case. Okay. So you see here, some of these angles are given with respect to x-axis or horizontal axis, and some of them are given with respect to vertical. So you should be able to write component. Doesn't matter whether it's given with respect to horizontal axis or vertical axis. So that should be your goal, okay? So this is for you, but I'll do one more where, let's say, x component may not be the always cosine, okay? X component may not always be cosine. So for that, let's say I'm doing this one here. It has a numbers and so on, and it has numbers rather than the symbol. So when you have numbers, what we do is we can say, okay, this is some sort of vector. See, it has a unit Newton. We haven't talked about that yet. The unit Newton is unit of force. So we can say, okay, that vector is F, and this angle is, let's say, theta. So here, F is 22 Newton, and theta is 30 degree. So now with that, so there is more information, this extra information here. So that means those values are known, but here those values are not given in this case. So doesn't matter whether given or not, we should be able to write them in terms of sine and cosine, okay? So what do we do? I have already assigned the coordinates. So let's write this as a positive x, this as a positive y. And then we want to start from the tail. We want to start from tail and go to the tip, going only, we are only allowed to move along the horizontal and vertical axis, okay, in the direction of horizontal and vertical axis. So since the angle is in this side, so I'm going to go past this side here. And once I reach, in line with that tip of that, then I can go in that direction. So this is along the y-axis. So this component is called y component of given vector. See, this is Fy. And this is x component now. See that? So now, in this case, see, the y component is y component adjacent or opposite to the given angle? Is y component means this here, this side here, right? The one that's pointing down along the y. Is that adjacent or opposite? Can you type that? Can you help me there? Is that adjacent or opposite of that triangle? So I see there are adjacents, that's right. So if it is adjacent, which trig the function is gonna pick? Adjacent picks which one? Sine or cosine? It's cosine. Okay, yes, great. So that means what is the y component? Now I can just write y component. I leave some room here for positive or negative sign, and then write the original vector f, and then this being adjacent, I write cosine. And the angle, I am denoting that as a theta, okay? So, and what's the sign of this y component? What's the direction? It's pointing down. Since we are assuming up as a positive, this gotta be negative. So that's how we do it. So once we know one is cosine, another one better be sine. Okay, I don't even have to look at the triangle because the other side gonna be opposite, and opposite picks the sine. Okay, so that's how I can directly write it. So now this is pointing. So which way is pointing? It's pointing to the right here on the screen, and right is positive x. So that means this is positive. Okay, so in this case, x component of this given vector force is positive f sine theta. See here, x component has a sign. So whether it's sine or cosine, it depends on angle. So keep that in mind. Okay, so this slide is posted inside the class slide folder on the Canvas, okay, in the Files tab. So you want to practice them and learn them, be fluent, okay, be fluent. Can you write that within 30 seconds? Can you write the components within 30 seconds? Okay, so that's how fluent you have to be, okay? So at the beginning, yes, it may take a little time. And if you can, try doing that. And then if you draw that on the paper, bring it to me and show it to me on the video here on the camera during our Zoom hour, and I can take a look and tell if you did it right or not. If you like, you can do that, okay? So that's that. And now I'm asking you this, okay? So I'm opening the pool. Go ahead, draw the right triangle, and then find the component. So I'm giving you 2 minutes. So take time, draw it on the paper or in your device, and then complete the triangle and find the components and choose an answer. And see, it's first asking for the x first, x and then y. That's the order this answer is given, okay? Not y and x. So keep that in mind. Thirty more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see how did we do here. So D first, and then C, and then B. We have all of these, okay? So let's see, I don't know the answer. I have to do it, okay? So tail is here, tip is here. So I want to go from tail to the tip. And this would be Y component. And this would be X component, okay? So in this case, this is the adjacent side of the angle. So this is F cosine theta. And here, being opposite, it is f sine theta. See here, I'm not writing positive and negative sign when I'm doing it right here. The reason is the arrow is right there. That's telling us direction. So I'm just writing value here, okay? But when I really need it, then I need to write. So for example, when I'm writing somewhere other than where the arrow is pointing, I need to write this. And since this is pointing down and we chose up as a positive, this must be negative f cosine theta. And similarly, x component going to be negative f sine theta. Okay, so both of them are negative. And in this question, it's asking us to first write x component. So that means we need to write one with the x component first. So that's why D is correct answer, just like many of you chose. Yeah. Okay. So some of you still had difficulty, as we saw here, right? So make sure you practice and learn, please, because we're going to be using that a lot throughout the semester, okay? Often, most of the time, we deal with vector or we work, the problems related to vector in terms of component most of the time. So that's why knowing this is very, very important. So now with that said, now we have tools to describe motion in 2 dimensions. And projectile motion is an example of such motion in 2 or even 3 dimensions, okay? So what is projectile? Anything we throw in the air. So after it leaves our hand or throwing agent, okay, once it out of contact of that, whatever threw it, then we say it becomes projectile. So if you fire a bullet, if you fire a bullet from a gun, once the bullet leaves the nozzle of that gun, what happens? It becomes projectile. When we throw a ball, for example, a basketball on the hoop, once it leaves our hand, it becomes projectile, okay? When we kick a soccer ball, once it leaves our foot, it's a projectile, okay? You throw a rock on the lake, once the rock leaves your hand, it becomes projectile until it hits the ground or the lake, okay? So that's the projectile. And to describe that, there are certain things we need to keep in mind, or when we keep that thing in mind, things becomes a bit simpler. Here is a video from this YouTube channel called Flipping Physics. And this person is high school teacher and has made really nice videos, okay? And the topics in the high school AP Physics, they are very similar to what we do here, okay? So if you feel like watching a video to learn physics, since the video I record is very boring, it gets very boring, right? So you can do that, okay? You can go and watch. But here I have brought a clip of the video. In this case, what's happening is person steps on a skateboard for constant motion, okay? So, and then there is a ball on the hand. Do I have something like that here? Okay, ball on the hand. So this person is throwing this ball straight up, like a free fall situation. But when we look at the video, first, the person is not holding camera on the hand. So camera is not moving with the person. So it's like I'm throwing the ball and you have the camera and you are taking the video. And see how the motion of the ball looks like. And when person holds the camera on the hand and see how the motion of the ball looks like. So that's why that's the kind of question I have asked here underneath. So while watching video, that's what you wanna watch, not the parked car over there, right? So, what do we see here is that the person throws the ball straight up. See, the ball following that person, or let's say person throws like this and keeps the hand in place, okay? He does not move the hand. Although whole thing is moving, the ball is also moving there, you can see, and comes back to the hand. So it follows a parabolic path, you see. So those multiple frames shows you that the ball is always, let's see if we can get that again, right? See how the ball is right above the hand, although it was thrown there, right? So why is the ball following this person, although the ball was thrown straight up? Any idea? Feel free to turn on microphone and talk. And also feel free to turn on videos, folks. You don't have to be hiding behind if your situation allows. Okay. I only hear the silence. Okay, let's keep it that way for now. But make up your mind. So now the camera is on the hand, see? So now ball is still following the hand, but now the path looks straight up and down. Now this is important. See here, this person is dropping ball here, okay? Dropping means you're not throwing or anything like that. You're just letting it go like this, okay? Dropping means just letting it go. So initial velocity in that direction is 0. So that's what this person is doing in the video. Oh, what happened? Okay. See how the ball was here initially? Now ball is here. So ball is moving sideways and also down. It's moving down. See, it is right under that hand all the time. See, it's following the hand. But also moving sideways. It makes sense. It goes up and down. So that's a free fall. But why it's moving also sideways here? Okay. Just like in the case of the ball that was thrown from the skateboard, here is dropped from a moving car. So car is moving, skateboard is moving. Remember, car is moving, skateboard is moving, and ball is on the car. So when we are driving a car and car is moving 60 miles per hour, what speed we are moving? Although we are sitting on a car, you know, since car is moving, we are also moving. So the ball was initially moving in that direction with the speed same as the car. So it's following the car on that direction because initially when it was dropped, it was also moving in that direction. So when we see this kind of path or trajectory, it has a motion in both horizontal and vertical direction. In vertical direction, the motion is like a free fall motion. It goes up and down, right, following the, hand all the time, right? It's like as if it's going just straight up and down along the vertical direction. In the horizontal direction, it moves with the same velocity as the car, as long as car is also moving with the same velocity, right? Like it's not changing the velocity, means velocity remains constant. So this is the main idea behind analyzing projectile motion. What is the idea? Along the vertical direction, the motion is free fall. And along the horizontal direction, motion is constant velocity motion. So that's it. That's the projectile, folks. So now with that, I have a quick question for you. You have a minute to answer this question. Thirty more seconds. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see how did we do here. Mostly A and B. So just like the ball followed the car, here is gonna follow the plane. So that means it's gonna just stay right underneath. So B is correct answer. Because when you drop the ball is moving with constant velocity. I mean, ball is also moving with the velocity same as the velocity of the plane. So that means it can follow the plane as long as plane is moving with uniform or constant speed. Okay, uniform means constant as well. Same, it's not changing. That's what constant uniform means. Okay, so if you chose A, what happened? That's wrong. Okay, and so either you are not paying attention when I was showing this video, or you somehow did not understood it. Okay, hopefully now you remember that. Okay, and so there is another video to reinforce the same idea here. Okay, so this ball gonna be shot straight up using a spring mechanism here, and then see what happens to the motion of the ball. So ball gonna be shot while this cart is moving, and cart moves with constant speed, and it comes back. See there? Did you ever imagine that's happening? But it does. Okay. The reason is simple. Ball, when it left the cart, ball was moving horizontally as well with the same velocity as the cart. So that means it's like two things driving with the same speed, two cars driving with the same velocity in two side-by-side lanes. So they are always together. Okay. But this ball goes up and down because it also has this velocity in vertical direction. So it also acting like a free fall. So all these are example of projectile motion. So a soccer ball kicked and the water coming out from this fountain, something like this, or a person doing this long jump thingy, right? So all these are the example of projectile motion. And of course, there is air, but unless the object is feather light, what happens is we can neglect the air resistance for most case. Okay. Unless, for example, let's say when you launch a missile from one country to another country, for example, that's a long distance, right? So in that case, what happens? Air gonna have a lot of effect. So that case, you cannot neglect the air resistance. But as long as we are not that, we're not throwing that far or something like that, and if the object is not like a featherweight, then we can neglect the air resistance. So in this class, we are neglecting the air resistance unless it is stated otherwise, okay? So if it doesn't say anything about air resistance, that means we say, okay, air resistance is negligible, just like it is on the moon, okay? Do you remember video from last class where the feather and hammer was dropped? Okay. So here is a question for you. Two objects, similar object, let's say, one is X, another one is Y. X is one thrown along the X direction horizontally, okay? Another one, Y, is dropped, okay? Just dropped like that, okay? So now when they arrive to the ground, which one arrives first? That's the question, okay? Or do they arrive at the same time? So you have a minute to answer this question. What do you think? And why? Also think about that. Oh, 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see how did we do. So mostly C. You say they tie. How do you know? Any idea? Yes, that is correct answer. So here is a sketch of such situation. You see one is dropped. It's in free fall here. And this is also in free fall, but it begins in horizontal direction first. So initial velocity was in horizontal direction. So initial velocity in vertical direction is 0 for both of them. And they go through a displacement of same height, okay? So if I say down is positive, then this is delta y is positive. And we know both of them are in free fall. So acceleration in y direction is g down. So three things same means you can solve for time and you should get same time. So that's the reason they tie, okay? So the time is same for both. That plays very important role in solving projectile motion problem. So what happens is in projectile motion problem, other things could be different. So you can write one equation for horizontal direction, one equation for vertical direction. And once you have two equations, time gonna be same in both equation because of this reason, okay? And this is linked to a video here where this experiment is being done, okay? And this is just a screen grab from that video, okay? You see both balls, they are side by side there, okay? So that means they are arriving to the ground at the same time as well, okay? So this is the most important slide in analyzing or understanding the projectile motion that includes all the things we talked about so far, okay? So we'll go through this, but looks like it's a break time. So let's take a break. So in 5 minutes, we're gonna learn how to think about projectile motion and how to solve such problems. Okay, folks, welcome back. So we were talking about how to analyze a projectile motion. And then we said, okay, projectile motion can be broken down into two separate components, horizontal and vertical component. Often horizontal component is denoted by x-axis and vertical component is denoted by y-axis, okay? So in this case, I am assuming right as a positive and up as a positive, but of course, we can also choose down as a positive, okay? So when we throw something at an angle, so in this case, let's try to follow this ball here. So it was here, let's say it was kicked something like this. So it goes there in first, let's say 10th of a second, and second 10th of a second or 2/10 of a second. It goes there and so on. So this is how the motion looks like. But while analyzing this motion, when we try to just do this, what happens is we don't know how to do that. But if we break this into x and y component, we can use the kinematic equation that we have already learned how to use in x and y direction. So for that, we take help from the motion diagram. So that's why we are emphasizing motion diagram in this class a lot. So when object is here, you can think of, okay, this being here along the horizontal direction and position being here along the y direction. And same thing goes here. When this is here, position along here is there. Sorry, along the y direction is that. And along the x direction is this position, right? So if we follow this ball that way, what do we see is along the vertical direction, see how the motion diagram tells us it's slowing down, eventually stops when it is at highest point, and then it starts coming down, okay? So that is the vertical motion of projectile. On the other hand, in horizontal direction, what happens? The separation distance between them are same, means velocity is constant. So the velocity is constant in horizontal direction. So that means the acceleration is zero. If velocity is not changing, it's not accelerating. So along the horizontal direction, acceleration is zero. But along the vertical direction, it's first slowing down, means acceleration is down. And then once it reaches the highest point, it starts speeding down again. So that means acceleration is down. So in both cases, acceleration is downward. So that means in free fall, acceleration is always downward. And it turns out that the value of that acceleration is this 9.8 meter per second square, which is same as the situation when we had free fall. So basically it's in free fall in vertical direction. So that's why that's the acceleration. So this would be y direction, x direction, it is zero. So since x direction, it is zero, that means all acceleration, if we were to add x and y direction using Pythagorean theorem, what happens? It is same as ay because ax is zero. So acceleration is same as acceleration in y direction all the time. Okay, so that one very important to solve projectile motion problem. So once we know projectile, it is projectile motion problem, even if nothing is given. Okay, what do we know already? Acceleration in the x direction is zero, and acceleration in y direction is that 9.8 meter per second square down. So rather than writing 9.8 meter per second square, I like to write lowercase g. Remember, we've been using that. And the direction is down. Okay. So once we know it is projectile motion and air resistance is negligible, even if the problem doesn't say anything, we know this already. Okay. So often in projectile motion problem, these are not explicitly mentioned. So you have to keep that in your mind. Okay. So now, let's say when object is at this point, for example, its displacement is this. So how do we find that displacement? So to find that displacement, what do is we find displacement along this direction using kinematic equation, and that is delta x. And that's what I have denoted that one over there, okay? And then we find displacement along the y direction using the kinematic equation in y direction. And once we have delta x and delta y, we can use Pythagorean theorem to find the displacement. Same thing goes with the velocity, okay? And about the velocity, what happens is if it is thrown in at an angle with respect to, let's say, like let's say x-axis or horizontal direction, then we have initial velocity Bix. So this gonna be the adjacent component of this, let's say, two components. So Bix gonna be positive V cosine theta, not sine, but cosine, because it's going to be adjacent for this angle when this angle is given. So this is going to be V cosine theta. So this one, no matter where the object is, this component of velocity is same as seen from this drawing, okay? Because acceleration is 0 in that direction. So that makes sense. So that means final velocity in the x direction is always equal to initial velocity. So if initial velocity is known in the x direction, which you can compute from using the given velocity and angle, then you also know the final velocity, initial and final velocities along the x direction is same, always same for projectile motion. Okay, so that you can actually figure that out. Okay, and along the vertical direction, what happens? The velocity is changing. That's what that is, right? So at any point, we can find the velocity along the horizontal direction and vertical direction. Once we have that, we can add them using Pythagorean theorem to find the final velocity. So that means it's going to be final velocity at x squared plus final velocity at y squared, like that. So you can find the velocities. But to find this velocity, you need to find this x component and y component of velocity. So for that, you may need to use, especially for the y component, you have to use kinematic equation. X component, it remains same. So if you know in one place, it's going to be always same. Okay. And then what happens at highest point? Velocity in the x direction is not 0 because it always remains same, but velocity in y direction is 0 at that point. So that's why it just keeps, drifting sideways. If both of them were 0, if the whole velocity was 0 at highest point, then this would just come down, okay? But that's not happening. Because of that, that's why it goes sideways even after the highest point. It doesn't just drop down. And another thing about this is, remember, the direction of acceleration can also be found by using the velocities at these individual points. So here I'm drawing one of these here, like a V2, and this is V3 at, let's say, third time interval. So in this case, for these two, we can think of V2 as an initial and V3 as a VF, because V3 is later compared to V2. So they are drawn tails together. So that means from tip of BI, we can draw change in velocity vector, so delta V. So see how, although we are looking at velocity at these 2 points, acceleration is still vertically down. So that's another way to verify that by using the skill or the knowledge we have already learned, okay? So that about the projectile motion. And I have another slide where I show you, okay, this is the general case that we saw in the previous slide. And this is a special case when object is thrown horizontal direction from some height, okay? So in that case, initial velocity is the velocity with which it was thrown. There is no sine or cosine. And velocity in y direction at the beginning is 0 because you are just throwing horizontally, means it does not have component at the beginning in this direction, at the moment of throw, okay? After we throw it, it starts drifting down, means now it picks up velocity because it has acceleration downward, right? So there are mostly two kinds of kinematic equation. And these are the things that I just talked about in the previous slide, right? And over here, see how the x component of the initial velocity can be written in terms of cosine, right? And even before we do that, for this, we need information about velocity and so on. But even without that, we know this. And by the way, here I wrote z for negative for down, okay? Down, that means I'm assuming up as a positive, okay? That means I'm assuming up as a positive. So instead of g down, I'm writing negative g because that's how it goes in the equation when we choose up as a positive. But if we choose down as a positive, then g gonna be positive because when we choose when we choose down as a positive, since g is always down, once we choose down positive, g becomes positive. I mean, the ay becomes positive, I should say, rather than g. G is always a number, positive number, of course. But even the acceleration in y direction becomes positive, okay? And then I was talking about the component. See, that's why this x component, this line here, picks up the cosine because it is adjacent, okay? And this is opposite, but in projectile motion, often the vectors are drawn from the same point here like that, okay? So this one and that one, they are same vector, just drawn at different places. So this being opposite side, what happens? It picks the sine, okay? So that's why we talked about how to write components. See, that's how we use the components while, analyzing projectile motion problem. And we do that later as well. So these are kinematic equations written explicitly for y direction. And we can do that for the x direction as well by changing y to the x. And when we have calculated this final velocity along the x and y direction, we can use Pythagorean theorem, just like I talked about, okay? So all these informations are in one place. And similarly, you can also find displacement using the Pythagorean theorem for the displacement in the x direction and y direction, right? That vector addition method we talked at the very beginning of this class. So those are the mathematical techniques you need. Okay, components, how to add components to find the total or final thingy here. And then also, of course, you need to keep remembering how to use kinematic equations, okay? Okay, with that, I have a question for you, and you have a minute to answer this question. Pay close attention to the, choices. Oh, forgot to warn, 30 more seconds. 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay. Let's see how did we do here. Mostly C, and that is correct answer. So at highest point, whole velocity is not zero, only the y component of the velocity is zero. X component is not zero. So because of that, velocity is not zero. If it was zero, then it would just come down. It's moving sideways, okay? And acceleration is always same, never zero for free fall or projectile motion. Acceleration is never zero, okay? So let's keep that in mind. So with that, now I have this question, and this question is solved in my note, okay, that I post on the pre-class assignment. So it is solved, but here I like to discuss about the thinking process you have to go through to solve any projectile motion problem. And just like I said, there can be mainly two kinds of projectile motion problem. One that is thrown horizontally, just like we are showing it here. Okay, this is one category. Another one is thrown at an angle. So both categories are solved with all the explanation on the note, okay? But here I like to emphasize certain things. So I have made some clicker question to guide you, how you want to think while solving projectile motion problem. Remember, often what happens when we see problem, when we read problem, we get stuck how to solve that problem. So here is the guide, how to proceed, how to go about solving a problem, not just projectile problem, any problem. That's how you need to think, right? So for example, first you sketch the situation, just like, we talked about solving kinematic equation, and the situation is already sketched. After you read once, you sketch the situation. So I already sketched the situation here, but that's what you want to do. How is the motion? What kind of projectile motion it is? Or thrown horizontally or thrown at an angle. Identify that, differentiate that, and draw the sketch. And once you have that sketch, and of course, to draw that sketch, you have to read whole problem once, okay? Once you have that, you can identify it is a projectile motion problem, right? You can tell this is a projectile motion problem. Once you know it is projectile motion problem, what are the quantities that you know even without reading the question? So that is what I am asking you, okay, here. So you have a minute to answer this question. Thirty more seconds. 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, so let's see what we got here. So we got most of them, okay, but looks like we are getting B more. So once we know it is a projectile motion problem, even without reading a question, we know two things: acceleration in x direction, which is 0, and acceleration in y direction, g down. These we know even without reading question, okay? So I think in this case, the way I ask this question would be D would be the correct answer in this case. But there are other things also we know in projectile motion problem once we read the question, okay, and pay a little bit attention. For example, AX, AY, they are already known. And in this case, once we read the question, what happens? We know initial velocity in y direction in this case is 0. BIY in this case is going to be 0. Why? Because it's thrown horizontally. And that velocity is given, so that means we also know VI x. So VIX is actually given. We also know BIY, okay, although it's not given. Okay, once we read the question, we can tell that. And BFX, it remains same all the time, right? Final velocity along the x direction, it remains same all the time. So we may also know that after we read the question, right? If Bix is given, we also know Bfx and so on, right? So C is also a probable answer here, but to get to the C, we need to read the question and, think about it. But D, we can figure that out even without reading the detail of the question once we know it is projectile motion problem, okay? So in this case, unfortunately, many of you chose this BFY as well. The final velocity, you cannot, in this case, you don't know final velocity here. For that, you need to use kinematic equation actually, okay? So yeah, so looks like not very good choices here. So that's why I bring this kind of question. These are challenging questions, right? So we need to think and think harder sometimes, okay? So with that said, now let's say, what are the things we know after we read the question, right? And among them, I have listed some of those, right? And question is same, so you don't have to keep reading the question, right? It's the same question. I mean, the statement of question is same, sketch is same. Now, I am assigning the coordinate. And see, this is slightly different from usual. Right is positive and down is positive. Okay, down is positive. Not up is positive, but down is positive. So anything that's pointing down, they're going to have positive sign. Down means positive in this case, based on our choice. So now this is the only thing that's changing. So read that question and then reread the question sentence by sentence and then write, answer the question. So in this case, I'm giving you 2 minutes. Pay close attention, read carefully. 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see what we got here. So mostly D. Nobody chose B. Okay, so now let's see how do I go about it. So we are choosing right as a positive and down as a positive. So displacement. So this starts from here and arrives here. So displacement is like this, but displacement in y direction gonna be just this. So it is pointing down, right? So overall displacement here is this, but displacement in y direction is this. So that's delta y, and this is displacement in x direction. So in the list, it starts with the displacement in y direction. So it's pointing down. And since this is down is positive, displacement must be positive. So that's why A and B, they are not the good choices. Okay, great. So now after that, it talks about acceleration in y direction. So what do we know about acceleration in y direction? Always g down. So in this case, down is positive. So that means it is positive z. Okay. So that's why this is not the correct response. So only one is remaining. So it has a positive, no sign means also positive sign. So this is Vix. So velocity, initial velocity in the x direction, which is this, okay? And it is positive because it's going this way and we are choosing that way as a positive, okay? So that's positive. So D is the correct answer in this case, okay? Just like many of you identified correctly, great, okay? So now once you have these thing, like things that's listed, now you want to think in terms of using equation, which equation to use in horizontal direction and which equation to use in vertical direction, okay? So that's the next step. See here, often what happens in a classroom, so there is a question and teacher starts writing, the answer. But here, by asking or framing question like this, I am, encouraging you or making you to read the question and go through the process of solving this problem interactively, okay? And I'm hoping you are paying full attention and learning how to do things, okay? Once we pick the equations, physics portion is done. Remaining is just mathematics, okay? Solving algebraic equation, which we did as the algebra test exercise, right? So now here is another question. I mean, since we are looking for displacement in the x direction, because it says how far will you land on the water, means we are looking for that, okay? How much is that? Which equation is best? So this equation looks like all of them are, looks like, some of them have x subscript, and some of them looks like don't. And depending on, like all of them have delta x and we are looking for delta x. So which is the appropriate equation to use in this case, okay? So that's what I'm asking. So what do you think? So in this case, based on what we know already along the x and y direction, which equation to use. So you have total 1 minute to answer this question. Forget to warn again, 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Okay. So we want to find displacement and which equation to use. Let's see what we got. We got all of them, and even one that is not there, E. There is no choice E. We are getting E choice. Okay, looks like A, B, C, all of them does not matter, looks like, right? And so to find displacement, let's say just like many of you, if we think we can use this equation, what are the things we need? Bix is known, so that's great. We also need time. Do we know time here? There is no time information in this equation, okay? Yes, we know acceleration in the x direction, which is 0, so that makes it 0 here. But we need time to find displacement, so we cannot use just this one equation and solve problem, okay? And basically, this is same equation, but it does not even have a x subscript, so I wouldn't, think using it. Now this one here, okay, looks like this one does not have time. See if we can use it. So to find delta x, ax is 0. So once we use ax 0 or acceleration in the x direction 0, this term not even gonna here. And basically it's simply saying initial velocity in the x direction is same as final velocity. Okay. So it looks like we need time. Without knowing time, we cannot find delta x. Okay. So that means one equation is not enough to solve this problem. Okay, we need two equations. So I think best choice would be D in this case. And once we can figure out what the time is, then we should be able to use this equation here. Okay. And so it looks like D is the best choice in this case, folks. Anything you like to add or ask here? So why not C for delta x? So if you use this equation, you cannot solve for delta x because see, ax is 0. Once you put 0, delta x not going to be there in the equation. So you cannot solve for delta x. Okay. Yeah, you can rearrange that. So that is delta x. Okay, great. But now, what is ax? 0. So when you divide something by 0, you know what happens? Yes, undefined. So that means you cannot solve for it, okay? Yeah, that's a great question. Okay, so moving on. So that means now we know to find displacement in the x direction, you need to find time. So to find time, we cannot use equation in the x direction. What we can do is we can use equation in y direction. So which equation is the one that we should be using, knowing these are the things we know, right? So which equation we should be using to find time interval so that we can use that time interval along the x direction and solve the problem, okay? So I'm opening this and you have 1 minute and 30 seconds. So 30 more seconds. And 5 more seconds. 5, 4, 3, 2, 1, and it stops. Let's see what we got. So mostly A, and that is correct answer. So we don't know final velocity in y direction. So because of that, we cannot use this equation, okay? With what velocity it's gonna arrive here, we don't know that, okay? So that means we cannot use it. And this is in the x direction, same equation in the x direction. So to find time, we need to use y direction. We figured from the last, slide. So this is not good. So this one has a displacement, which we already know. This one has the initial velocity in y direction. Initial velocity in y direction is 0. We talked about that, although I did not list it here. So that means this is going to be 0. And we know acceleration, so we can solve for the time interval. Okay. Once we have time interval, then we can use that time interval to find displacement in the x direction. So solving projectile motion problem often involves writing two suitable equation and solving them, okay, where time becomes the common for both equations. And this problem is fully done with all the explanation, okay. Here I am choosing up as a positive, so that's why AY is negative Z. So I simply change the coordinate to show you we can choose up or down, okay? And see all those discussion, with that, we're choosing this equation for the, and just like we did in one of the clicker questions. So AX0 means that. So velocity, and now we need time interval, and to find time interval, we use the equation we just taught in the last slide, which is basically same equation in y direction, okay, which is done in this slide. And it's fully done with up to the final answer. And I don't know if I told you or not, although I made this question saying hanging lake. So if you know hanging lake, you cannot jump and swim in the hanging lake, okay? It's just, I made the question over there. So this is where you are, rather than just, going like this, you are now going something like this. So this is like you become projectile, like you were, you know, thrown at an angle with the horizontal, and that's what this question is. So you need to go through the same process and solve this. So my suggestion for every one of you is now go look at just the question without solution and see if you can solve them. Okay, be fluent on them. And then there are some suggested problem from the book. These are also example problem, means they are already solved, but you do not want to just read the solution. Remember, by watching a video of how to ride a bike, you cannot ride a bike. You cannot learn how to ride a bike. You have to actually climb on the bike and, push the bike. Same thing goes with the solving physics problem. You have to do it just by reading or looking at what other person, how other person do it. You want to learn how to do it. You may have answer of that particular question, but you don't know how to solve any such problem. So keep that in mind and honestly go through them. Okay. And before I let you go, I have this question here related to this. And what do you think? You have a minute to answer this question. Oh, forgot to warn, didn't I? Okay, we don't have much time, so I'll be closing in 15 seconds, folks. Five more seconds. 5, 4, 3, 2, 1, and it stops. Okay, let's see, how did we do? So mostly A, and that is correct answer. Okay, release means drop. So just like when we drop a ball from moving car, what happens? This has the initial velocity same as the velocity of the car. Similarly, this plane was going up vertically, right? And when you release, so that means the cigarette also has the same velocity as the helicopter at the moment we release it. And then since the helicopter was going up, the cigarette was also going up. So that means it just follows the helicopter. But since helicopter has an engine, it may take different direction, but helicopter is not in free fall, but the uh, cigarette is, because there is no other forces other than gravitational force. So it becomes as if it was thrown with that initial velocity. So that's why it goes something like that. Okay. So that's that, folks. So if you have to leave, please feel free to leave. I have these two links on this. So in this slide, so this slide is posted. You can watch this video later. But if you have time, this video is about 1 second, I mean, few seconds long. You want to stay and watch if you have time. So here is being shot at an angle. So there is that doll over there. So laser pointer is pointing on the doll, means it is, the gun is pointed on the doll. The moment gun is fired, what happens? Doll is released. The question is, will the bullet hit the doll? And turns out it does. Okay. Why is that? Okay. So think about that. So there is slow motion. Okay. Okay, that's all, folks. And again, link of this video and similar other video is on the slide. You can play that, watch that. Okay. So I'll see you next week. Okay. And of course, if you have quick question, you can stay behind and ask me here. But I will also be on Zoom soon at 10 o'clock today. Okay, so you can come there. Oh, come on.